Hello, for today's video lecture, we're going to be talking about frames and machines. So a frame or a machine is going to be any structure that has at least one member that is not a two-force member. So all we need is just that one member to make it either a frame or a machine and not a truss. So the difference between what's called a frame and what's called a machine is whether or not this body is rigid. So a frame is going to be rigid. Imagine something like this stool over here. So this stool, the leg of the stool, it's connected here up the top, so it's got forces there. Connected here, it's going to have forces there. And it's in contact with the ground, it has forces down here. So this right here, this leg is going to be one member that is not a two-force member. And also this whole thing is rigid. If I pick it up and move it around, none of the parts move relative to one another. It kind of acts as a whole solid body. A machine, on the other hand, is not going to be rigid. So this pair of scissors over here is an example of a machine. So for this pair of scissors, if I'm cutting something, I imagine something in here, I would have force right here, force at the pin in the middle, and my hand would be exerting a force over there. So this blade here is not a two-force member, therefore it's either a frame or machine. And since the kind of two halves of the scissors can move independently, it's not rigid as a whole. And that means that it is a machine and not a frame. So because we can't assume that each member is a two-force member, we can't use the method of sections and the method of joints. And I'm going to explain in a second why that is. So it's still useful to identify two-force members. So an example in here, this member down here is connected at either end. There's nothing in the middle. These cross beams would be two-force members. I still want to do that, but I can't use method of joints, method of sections as a whole. So let's look first at the method of joints. A member that is not a two-force member does not have a single unknown force along a known direction. So here, I'm looking at member BD. If I were to kind of apply a force right in the middle of that, now it's going to be connected here at B, here at D, and have a force in the middle. No longer a two-force member. And that means that this single tension force, FBD, basically doesn't stand anymore. So I need to replace that with a X and a Y force over here, and an X and a Y force over here. Since that happens, now I've got a lot more unknowns than I had before, and basically the method of joints is not going to work anymore. I'm going to have too many unknowns to deal with. A similar thing will happen in the method of sections. Say I've got BD over here. I apply a force somewhere along the middle, again making it not a two-force member. Now this single force that I had there before, since it was a two-force member, I don't know anything, so we're going to have forces in the X, forces in the Y, and when I cut something like this, it can have a moment internal to that piece. So now I've got a lot more unknowns, all because this one piece is not a two-force member. So method of joints, method of sections basically become unusable when I've got a frame or machine. So what are we going to do instead? The analysis of frames and machines is usually a little bit more complicated. I'm going to go into some of the basic assumptions here, but I've got another video talking about the full analysis of frames and machines method. The basic assumptions are as follows now. So if the structure you're analyzing is in static equilibrium, like most everything we're looking at in statics, and it's independently rigid, we can analyze it as one big rigid body. Also, each component, if the stool is just sitting in there, it's in equilibrium. The leg of the stool is also going to be in equilibrium, and we're going to use that to our advantage. So each part we can analyze as a body in equilibrium. And the last part is going to be Newton's third law. So whenever you've got two components in contact, there's going to be a set of equal and opposite forces on either side. So this is, imagine the stool connected with the seat of the stool, so the leg connected with the seat. The forces that the seat exerts on the leg are going to be equal and opposite to the forces that the leg exerts on the seat. And so I'd separate those two pieces, but I have those interaction forces where they're in contact. So with that, that's all I have for this video lecture. Thank you for watching, and I hope to see you again.